We're now going to continue section 8.6 and continue discussing the dot product. Quite often we will have a problem that in order for us to be able to work the problem, we need to be able to decompose a vector into the sum of two other vectors. So I want to look first at this with you. And this is the idea of what is called a projection of vectors. So what we want to be able to do as you look at this picture is you want to take vector u and we want to be able to break it down into two other vectors added together. So let's say vector w sub 1 and vector w sub 2. All right, so we want to take vector u and we want to decompose it into these two vectors such that when we add them together, we get the same thing that we started with. Now, one of these vectors we're going to call the projection of u. All right, and so that's what we have right here, the projection of u. So this would be like w sub 1. And then the other vector is going to be perpendicular to this. And so we would tend to call this one PERP of vector u. And this would be like our W2. Okay, and so that's what we're going to be looking at in this section, is taking a vector and decomposing it into the projection vector and also the perpendicular vector, and knowing that when we add them together, we should get the original vector u. Okay, so let's start with the formula, and let's get that down, and then we're going to look at an example. So it says let u and v be non-zero vectors. The projector of u onto v is the vector, and they give us a formula to find the projection vector. And so that formula says we do the dot product of u and v, that's the top part of the fraction. On the bottom we do the magnitude of v squared, and then we multiply that whole quantity by vector v. Okay, so let's look at how this works in an example. Find the projection of u, and vector u is 2, 4, onto vector v, which is 7, negative 1. And then write u as a sum of two orthogonal vectors. Remember, orthogonal means perpendicular, one of which is the projection vector. Okay, so let's start, and we'll go back and get this formula, and let's write this formula down, and let's work on finding that projection vector first. Okay, so I'm going to write the formula down so that we can work with that. Okay, so our projection vector is going to be equal to the dot product of u and v over the magnitude of v squared, and we're going to multiply that whole quantity by vector v. Okay, so let's start with the top part where we're doing the dot product of our two vectors. So I'm just going to come off to the side and do that calculation. Remember, the dot product implies that you're going to take the first two components and multiply them together. So 2 times 7 is 14. And then I'm going to add the second components multiplied together. So 4 times negative 1 is negative 4. All right, so our dot product is going to be positive 10. Okay, now let's find the magnitude of vector v. So we'll also have that to plug in. So again, remember, your magnitude is found by taking the square root of your first component squared plus your second component squared. So we'll have 7 squared plus negative 1 squared. So 7 squared is going to be 49. Negative 1 squared is going to be positive 1. So we're looking at the square root of 50 for our magnitude. Okay, so let's go ahead and go back to our formula and let's plug these values in. All right, so I'm going to have my dot product on the top, which we said was 10. I'm going to have the square root of 50 on the bottom, and then I have to square it. And I'm going to be multiplying it by vector v. So that vector v is 7 and negative 1. All right, I'm going to do a little simplifying. The square root of 50 squared is just going to be 50. And 10 over 50 is going to reduce to 1/5. And remember that we can take that constant term and distribute it among the vector components. So 1/5 times 7 is going to be 7 over 5. And 1/5 times negative 1 is going to be negative 1 over 5. Okay, so this is going to be our projection vector. Okay, so I'm going to erase so that we have a little bit of room, and then we're going to work on the next part of this problem. So I'm just going to write our answer down here so we have that. And it's 7/5 and negative 1 over 5. Okay. All right, so let's look at the next thing that we're asked to do. So we found the projection vector. The next thing is that we want to write u as the sum of two orthogonal vectors, one of which is the projection vector. So in other words, we want to take u and we want to write it as two vectors that are added together. One of these vectors is the projection vector that we just found, and the other vector, remember, is going to be the perpendicular one. Okay, remember our picture. We said vector u is going to be decomposed into these two vectors, the perpendicular and the projection. And so that's what we're seeing right here. All right, so let's plug in what we know right here. Okay, so I know vector u, and I know that that is the vector 2, 4. And I know the projection vector because I just found that. That's 7 over 5 and negative 1 over 5. And what I don't know is this perpendicular vector. So in order to do that, let's treat this kind of like an equation from an algebra class, and let's solve for the perpendicular vector, which means essentially that I need to take this projection vector and I need to subtract it off from both sides of the equation. All right, that's going to allow it to cancel over here. And let's do our subtraction. Okay, now remember when we subtract vectors, we're subtracting like components. So in other words, I'm doing 2 minus 7/5. And you can either do that on your calculator or do a common denominator. You could write the 2 as 10 over 5 and then subtract. So that would give you 3/5. And then we're going to do 4 minus a negative 1/5. And again, that's really going to be 4 plus 1/5. All right, and so that's going to be 21 over 5. And this is going to equal our perpendicular vector. All right, so now we have essentially done what they asked us to do because they wanted us to write vector u as a sum of two orthogonal vectors. So now that we know what those vectors are, let's actually go in and add them together. And so in other words, we can say, just to kind of sum this up, we can say that vector u is going to be the projection vector plus the perpendicular vector, which is going to be the projection plus the perpendicular, And that is going to be your 2, 4 that we started with. Okay, and so we'll just look quickly. I mean, we've completed the problem, but we'll look quickly now at what that graph looks like just to identify what's happening. Again, here's vector u drawn for you. Here's your projection vector, here's your perpendicular vector, and basically what we're saying is that when we add the projection vector to the perpendicular vector, we get vector u.